In this video, we're going to delve into the working of an internal combustion engine, breaking down its key components, exploring how it operates. An engine is a marvel of engineering, composed of several vital components working in harmony to convert fuel into mechanical power. Let's take a look at these components. The foundation of an internal combustion engine is the cylinder block. It houses the multiple cylindrical chambers, called cylinders, where the magic happens. The diameter of these openings is called the cylinder bore. Most cylinder blocks are created through casting, typically cast iron. The machining process defines the block's intricate shape. The block contains intricate passages for coolant flow. These passages help regulate the engine's temperature, preventing overheating. Inside the block, you'll find oil channels that route engine oil to different parts, ensuring proper lubrication and reducing friction. Advanced manufacturing techniques and materials result in lightweight yet robust cylinder blocks. This aids in improving fuel efficiency and overall vehicle performance. Next, pistons, connecting rods and crankshaft. Pistons are cylindrical components that move up and down within the cylinders. Piston rings create a seal between the piston and the cylinder wall, preventing the escape of combustion gases. They are usually made from aluminum alloy for lightness and heat resistance. Connecting rods connect the pistons to the crankshaft with crank pins. This converts the linear motion of the pistons into the rotational motion of the crankshaft. Crankshaft die forging method that involves shaping metal through controlled deformation under high pressure, producing high-strength crankshafts. It is then machined for removing excess material from a block of metal to create desired shape. This method is used for precision and customization. The crankshaft may undergo heat treatments, such as quenching and tempering, to enhance its strength and durability. The crankshaft ends are now connected inside the cylinder block. Engine head. It often called as the brain of the engine, the cylinder head plays a critical role in managing the flow of air, fuel, and exhaust gases. Cylinder heads have two types of ports: intake ports that allow air and fuel into the cylinders, and exhaust ports that release the combustion byproducts. Valves are placed inside the ports, which regulate the flow of air, fuel, and exhaust gases. The intake valve lets in the air-fuel mixture, while the exhaust valve releases the spent gases. A camshaft features a series of cam lobes, each carefully designed to control the movement of a specific valve. The camshaft is positioned above the cylinder head, and the camshaft dictates the precise timing of valve openings and closings, ultimately shaping an engine's performance. The shape of each cam lobe, known as the cam profile, determines the timing and degree of valve movement. The engine head with valves and camshaft is attached to the top of cylinder block. The most common method is a bolted joint, where bolts or studs secure the cylinder head to the engine block using precision torque. Before assembly, surfaces of the cylinder head and engine block are machined to ensure flatness and proper sealing. A gasket is a specially designed material, is placed between the cylinder head and engine block to create a tight leak-free seal. The timing belt, or timing chain, connects the crankshaft and camshaft, ensuring that they rotate in perfect synchrony. Tensioner and idler pulleys maintain the proper tension of the timing belt, preventing slack and ensuring smooth operation. A timing belt is made from rubber and reinforced with strong fibers, ensuring durability and flexibility. On the other hand, timing chains are usually made of metal links, offering robustness and longevity. Timing chains are internally lubricated by engine oil, reducing friction and wear. Inlet and exhaust manifolds. These components are like the lungs and arteries of the engine, regulating the intake of air and the expulsion of exhaust gases. Inlet and exhaust manifolds are often made from materials that can withstand high temperatures and corrosion, such as cast iron or stainless steel. The inlet manifold is responsible for delivering a mixture of air and fuel to the engine's combustion chambers. The exhaust manifold collects and channels exhaust gases from the engine cylinders to the exhaust system. Fuel injection system. An electric fuel pump draws fuel from the tank and delivers it under pressure to the fuel rail. The fuel rail distributes pressurized fuel to the injectors, ensuring even fuel to each cylinder. Fuel injectors spray fuel in a fine mist into the combustion chamber, allowing for precise control over fuel delivery. Let's see how these components operate together and how engine works. Combustion process has 4 strokes. 1. Intake stroke. The intake valve opens as the piston moves down, allowing a mixture of air and fuel to enter the combustion chamber. 2. Compression stroke. The piston moves up, compressing the air-fuel mixture, raising its pressure and temperature. 3. Power stroke. In gasoline engines, a spark from the spark plug ignites the compressed mixture, creating a controlled explosion that drives the piston down. Diesel engines on the other hand use compression ignition. A high compression ratio compresses the air-fuel mixture into a smaller space before ignition. This compression increases its temperature and pressure. Where the air-fuel mixture ignites due to high compression temperatures, the force of the explosion pushes the piston down with tremendous power, converting the explosive energy into mechanical motion. 4. Exhaust stroke. The piston moves back up, expelling the spent gases through the exhaust valve. To ensure proper lubrication, engine oil is pumped throughout the engine. Engine oil forms a thin protective layer between moving parts, reducing friction and wear during operation. The oil pump is often driven by the engine's crankshaft, ensuring a continuous flow of oil. Engine oil lubricates valve guides and camshaft in the cylinder head, and it lubricates pistons and crankshaft in cylinder block, ensuring smooth movement. The oil pan is situated at the bottom of the engine and serves as the main container for engine oil. To manage the intense heat generated during combustion, these engines incorporate a cooling system. This system uses a mixture of water and coolant to regulate engine temperature with the help of the radiator. As the engine's pistons move up and down, they drive the crankshaft's rotation, converting reciprocating motion into rotational energy. This rotational energy is now transferred to the transmission system to push the wheels forward. And there you have it, the captivating symphony of an internal combustion engine. A harmonious choreography of parts and processes turns fuel.
Thank you. Watch my video, subscribe my channel.